Iowa Precision Industries, a company dedicated to the innovative development and manufacturing of coil processing equipment, introduces the Automated Enclosure Manufacturing Line. IPI has married time-proven cut-to-length punching, notching, and forming processes to reduce work in process, inventory, setup times, and to simplify manufacturing scheduling. This automated system manufactures from pre-painted coil stock enclosures for air treatment systems. It consists of a main processing line that incorporates punching and notching, wing-bending flanges on all edges, and a forming station to develop a U-shaped wrapper. 3 adjacent lines produce from coil stock and feed top rails and side channels to the main line. Each adjacent line has its own dedicated decoiler, flattener, and roll former. The processed components are assembled together and fastened with a Tox-type metal displacement locking system, rather than welding or riveting. A hydraulically actuated upender rotates the coils so the axis is on a horizontal plane, ready to be picked up by the coil car. The coil car lifts the coil from the upender, using hydraulic power to raise and lower the coil, as well as to drive the coil car down the track in order to load the coil onto the uncoiler. The uncoiler mandrel expands by hydraulics to provide a positive clamp on the inside of the coil, and a hydraulic drive pays out the material. As the material forms a loop between the uncoiler and the next operation, a dancer arm resting on the loop controls the speed of the coil payoff to maintain loop height. Straightening rolls take the coil set out of the material to provide the flatness necessary for the end product. The rolls are adjustable so that one side of the material can be worked more or less than the other as is required. The material flows through the straightening rolls continuously without stopping, so as not to induce roll marks. Since the following operations require that the material start and stop, a looping pit allows the continuously running material to accumulate in the pit during the stop time. Hydraulic punching and notching operations put in all holes and the edge and corner notches required in the part needed for completion of the assembly process. Hand crank adjustment allows the repositioning for different part widths. A turnover mechanism flips the parts over to the correct orientation for the continuation of the fabrication process. This ensures that any burrs created by the punching and notching units will be toward the inside of the finished product. The punched and notched flat blank is conveyed to a dual leaf brake system, which positions the part, clamps it, and actuates the hydraulically powered leaf brake, bending up a 90-degree flange on both sides of the part simultaneously. The part is transferred into a multiforming process that bends up flanges on each end and forms the blank into the U-shape needed to fabricate the enclosure. An automatic positioning system moves the leaf brake heads out to the ends of the part. The part is raised up to clamp it against the top dies, and the leaves rotate, bending up the end flanges on the part. The leaf brake heads then move to the position of the interior bends, and the part is bent up into the U-shape. All functions are sequenced by the machine's onboard PC-based control system. The formed-up parts are then ejected onto a staging conveyor where the operator will insert the top rails of the enclosure. The top rails are produced in 2 of the 3 adjacent lines and feed parts to a common button placement and snap-in station. The machine roll forms the top rails and transfers them to a staging area, where an operator inserts 2 connector buttons into each rail and places them into the shuttling bed of the snap-in station. The station shuttles the parts, 4 at a time, where a hydraulically actuated ram presses the buttons onto the rails. The shuttling system reciprocates, producing 4 empty nests to be filled by the product of 1 top rail line, while the top rail buttons that were produced by the second line are being pressed into place. The operator places 2 of the top rails onto each U-shaped wrap to provide the 4th side of the enclosure body, and then slides the assembly onto the conveyor that feeds the parts into the fastening station. The fastening station uses a Tox-type metal displacement locking system, rather than welding or riveting, to lock together the lower corners of the enclosure. The assembly is then transferred to the upper corner fastening station. The third adjacent line produces channels from coil stock in straightening and roll forming processes. The operator places temporary fixtures and then the two channels into the fixtures that support them on the inside of the enclosure assembly. The assembly is then transferred by conveyor belt into the final fastening station, which locks both channels into place simultaneously. The support fixtures are then removed from the enclosure assembly and placed onto a return conveyor for reuse up the line, and a foam rubber sealing strip is applied to finish the enclosure assembly process. Finished enclosures are then transported to the next assembly cell in the manufacturing process. Iowa Precision has the experience and the know-how to custom design an automated system for your application, to reduce your work in process and streamline your manufacturing processes to be competitive in today's world marketplace. To find out how you can benefit from an automated system in your plant, contact your Iowa Precision representative.